Factorizing. Factorize fully. X squared minus 3x minus 28. 6x squared minus 11x minus 10. 6x squared minus 12x. And p squared minus 4pq plus 4q squared. So here we have a quadratic. And we know that there's going to be an x in the front of each bracket because we have an x squared. So the two factors each begin with an x. And the numbers at the end of each factor are going to have a product of minus 28 and a sum of minus 3. So the numbers at the end need to multiply together, a product multiplied together to give minus 28, and a sum of minus 3. So they need to add together to give minus 3. So if I have a look at minus 28 and I need the factors of minus 28, since this is a minus, I know that the signs are going to be different inside my brackets. If this is a plus, I would know that the signs are the same, but it's a minus, so I have different signs. And factors of 28 that will add together to give minus 3 are going to be minus 7 and 4. So minus 7 multiplied by 4 will give me minus 28, and minus 7 plus 4 gives me minus 3. So to factorize x squared minus 3x minus 28, I get x minus 7 and x plus 4. I can check on my right by multiplying out my brackets. X by x is x squared. X by 4 is 4x. Minus 7 by x is minus 7x. Put them together to get minus 3x. And minus 7 by 4 is minus 28. Second one, 6x squared minus 11x minus 10. So there's two ways that you can do this. You can experiment with factors of 6 and minus 10 so that the sum of their inner product and outer product is minus 11x. So sum being add and product meaning multiply. So these sorts of questions can take a bit of work when the coefficient of x squared is greater than 1 if you use this method, which is like trial and error. So eventually we would end up with 3x plus 2 and 2x minus 5. So factors of 6x squared in the front of my bracket are going to be 3x and 2x because 3x by 2x is 6x squared. And then we need to decide on what our other terms are going to be. So we can mess around with the factors of 10 and end up with 2 and 5. And we can check are we right by multiplying or getting the product of the inner and outer terms. So the inner terms, 2 by 2x is 4x, and the outer terms, 3x by minus 5 is minus 15x, and 4x minus 15x is minus 11x, which is what we want. We can check are we right by multiplying out the brackets. 3x by 2x is 6x squared, 3x by minus 5 is minus 15x, 2 by 2x is 4x, put them together to get minus 11x, and 2 by minus 5 is minus 10. But I have a different method that I like to use for this, so I'm going to show you how to do that now. So I want to factorize 6x squared minus 11x minus 10. So what I'm going to do is bring down the 6x squared here, and bring down the minus 10 here. And then what I'm going to do is multiply 6 by 10 to get 60, and I'm going to list my factors of 60 over here. So I have 1 by 60, 2 by 30, 3 by 20, 4 by 15, 5 by 12, 6 by 10. And I need to choose one of these factor pairs so that when I put them together, I end up with minus 11. So my factor pairs that will end up giving me minus 11 could be 4 and 15. So I'm going to bring down the minus 11x and I'm going to change it to 4x minus 15x because 4 minus 15 gives me minus 11 and 4 multiplied by 15 gives me 60. So next what I'm going to do is I'm going to group together my first two terms and factorize those. So what will divide into 6 and 4? Well, that's going to be 2. And what will divide into x squared and x? That's going to be x. So 2 into 6 goes 3 times. X into x squared goes x. and 2 into 4 goes twice, and x just divides into x. So my highest common factor is 2x. 2x divides into 6x squared and leaves me with 3x. 2x divides into 4x and leaves me with plus 2. Then I'm going to do the same on the right hand side, minus 15x and minus 10. So what will divide into both of them? Well, minus 5 will divide into both of them. So minus 5 into minus 15x is going to give me 3x. And minus 5 into minus 10 is going to give me 2. And I notice that what's inside my brackets matches. So one of my factors is going to be 3x plus 2, because that's inside both of my brackets. And my other factor is going to be what's left over, which is 2x minus 5. So if I want to factorize 6x squared minus 11x minus 10, I end up getting 3x plus 2 times 2x minus 5, which is the same as I got the first time, but it's just a different method. Okay, part 3, 6x squared minus 12x. Well, if the constant term is missing from the quadratic polynomial, it is only necessary to take out x and the highest common factor of the coefficients. So basically, again, we're just going to use our HCF method. So we have a look and we see what will divide into 6x squared that will also divide into minus 12x, and it's going to be 6x. So 6x into 6x squared leaves us with x, and 6x into minus 12x leaves us with minus 2. So our HCF is 6x. And then the last one, p squared minus 4pq plus 4q squared. So each factor contains a number of p and a number of q. This quadratic is a perfect square. And we're going to work this in the same way that we worked part 2. So where we're going to break up our quadratic trinomial into 4 different terms, and then we're going to factorize by grouping and then bring back our factors together at the end. So let's have a look at this one. Okay, so how I worked the last one was I brought down the first term, which in this case is a p squared. So I'm going to write that down there. And I'm also going to write down my last term, which is 4q squared. So I'm going to write that down here. And then what I'm going to do is I'm going to multiply the number that would be in front of each of these terms. In this case, it's a 1. 1 multiplied by 4. So my factors of 4 are 1 multiplied by 4 and 2 multiplied by 2. I know that this 4q squared is positive. So now I have a look at my signs. I see that this is positive. So I know that my signs of each of these terms will be the same. And this is a minus, so they're both going to be minus. So I've got minus something, minus something. So what I need to do is choose 2 terms that when one of my factor pairs of 4, and I need to choose 2 terms containing those factor pairs that when I add them together, I end up with minus 4pq. So minus something has to give me minus 4pq. So let's say I was to use minus 1, minus 4. Well, that would give me minus 5, which is not what I want. So if I use minus 2, I will get minus 4. But I'm looking for minus 4pq. So minus 2 watt will give me minus 4pq. And it's going to be minus 2pq. Minus 2pq will end up giving me minus 4pq. So I brought the p squared down here, the plus 4 squared down here. I said 1 multiplied by 4 is 4. My factors of 4 are 1 by 4 and 2 by 2. I have a look here and I see this is positive, so I know that these signs are going to be the same. And this is minus, so they're both going to be a minus. And I need to choose one of these factor pairs that when I put them together, I end up getting minus 4. So I'm going to go with 2 and 2, because minus 2 gives me minus 4. But I have to stick on a PQ to each of them, because minus 2PQ minus 2PQ gives me minus 4PQ. So now I have 4 factors, and I'm going to group them, and I'm going to factorize each group. So if I have a look at the p squared and the minus 2PQ, and I know that p will divide into both of them, so p is going to go outside my bracket. P into p squared goes p, and p into minus 2pq goes minus 2q. So p divides into p squared, leaves me with p. P divides into minus 2pq, leaving me with minus 2q. Now I'm going to factorize the right hand side. So I've got minus 2 and 4. So I'm going to go with minus 2, because that will divide into both of those. And then I'm going to have a look and see what letters are common. Well, q is common. So minus 2q is going to be one of my factors. Open up my bracket. Minus 2 into minus 2 cancels. Q into q cancels. And I'm left just with a p. And then minus 2 into 4 is going to go minus 2 times. And q into q squared is going to leave me with q. So I end up having p into p squared leaves me with p. P into minus 2pq leaves me with minus 2q. Minus 2q into minus 2pq leaves me with p. And minus 2q into 4q squared leaves me with minus 2q. So I notice that what's inside my brackets is the same, so that's going to be one of my factors, p minus 2q. And then I'm going to bring down this p, and I'm going to bring down this minus 2q. And there I have my factors. And I notice that they are the same, they are the exact same, p minus 2q multiplied by p minus 2q. And this can be rewritten as p minus 2q squared. So that's why it's called a perfect square, because it is itself multiplied by itself. So for part 4, the factors of p squared minus 4pq plus 4q squared were p minus 2q and p minus 2q, which gives us p minus 2q squared. This is known as a perfect square.